Hello everyone, I'm going to be introducing you to a new BMS board today from Apex. It's called the Apex 48100 BMS board, and as the name suggests, it's a 100 amp 48 volt designed to communicate with 16 individual cells. And it comes as the BMS board itself, which is this, which has a heatsink on the back, which is something we need to just be careful of. A bit later we'll go into that in more detail. Comes with a screen, some screws for connecting the power cables, which would be here. It comes with two of these cables, one with a black connector on the end, and the other one with a white connector on the end. We'll look at that in a bit more detail. And this little cable, which is used to connect the screen to that connector on the board. So let's get into this. The purpose of this video is to show you how to connect the BMS to the individual cells. But before we get into that, I would just like to mention a few safety issues. We're going to be working on a 100 amp battery, and whenever you're doing this you should wear gloves, insulated gloves, and eye protection. The quality of the board is very good. Heat dissipation has been well handled, and obviously a quality product. Of the two wiring harnesses that are supplied, the black one connects to cells numbers 1 to 8, and the white one connects to cell numbers 9 to 16. And this is how they connected. On the black one, the black wire on the right hand side here is the 0 voltage. It's connected to the negative of cell number 1. The white wire is connected to the positive of cell number 1. The yellow to positive cell number 2, the orange positive cell number 3, and the red to positive cell number 4. The two black wires in the middle are connected to a temperature sensor, an NTC, there it is over there, which goes between a couple of the batteries to monitor temperature. We'll look at that in a bit more detail later. Then moving on from there, the next white wire is positive cell number 5. The yellow wire is positive cell number 6. The orange wire is positive cell number 7. And the red wire is positive cell number 8. The remaining two black wires are connected to another temperature sensor, which is also strategically placed between the batteries. Here is the first bank of batteries containing cells numbers 1 to 8. We've numbered them for ease of reference. That's cell number 1, number 2, 3, 4, 5, 6, 7, and 8. And we've numbered the leads that go to the black connector correspondingly. So this is 0 volts, it's on the negative of cell number 1. Then connection number 1 is white, it goes to the positive of battery number 1, yellow to the positive of battery number 2, 3 to the positive of battery number 3, the orange one, and the red one goes to the positive of battery number 4. This is the NTC, which is connected to the two black wires that are next in the harness. And then going on from that, we've got white again goes to positive battery number 5, 6 yellow goes to positive battery number 6, orange 7 goes to positive battery number 7, and 8 goes to positive battery number 8. We'll continue, we'll put the next set of cells in shortly, and we'll assemble the whole battery and see how that goes together. We need to do some testing on this, and we'll do that in a moment. This is the second sensor that's the NTC temperature sensor on the black harness. That goes in an appropriate place between the batteries there. Just a point, when working on these batteries, it's not a good idea to use a flat spanner to tighten these nuts. There's a possibility of shorting the connections on the cell, and believe me, these deliver 100 amps. If you short them, the result is spectacular and can be quite dangerous. By far the better thing is to use a socket to tighten the nuts on the cells. Now we're going to test that we've got our connections right. So what I've got here is I've got the negative of my meter is connected to the 0 voltage, which is the negative of cell number 1. That's our reference voltage, and we're going to test the lines in this black connector and make sure that the voltages progressively increase, which will tell us whether we've wired it up correctly. So I'm just going to adjust the focus here a little bit and the angle. Right, so here we go. We'll start off with a black line, which should be 0 volts. And it is. Then the next one is the white line, which should be just under 3 volts, which is the voltage of one cell. And that's correct. Then the next one is the yellow line, which is the voltage of 2 cells, 6.59, that's correct. And next one is 9.89, which is cell number 3. Cell number 4 should give us 13.19. That's correct. Then we have these 2 black connections, which should have a minimal voltage, a few millivolts on them. That is the NTC, the temperature sensor. Then the next line is the white, number 5, 16.5 volts roughly. Cell number 6, 19.8 volts. Cell number 7, 23.1 volts. Cell number 8, 26.4 volts. And then our second temperature sensor should be minimal voltage again. Yeah, all looks good. It's very important to do this before plugging that black connector into the BMS to make sure that the wiring is right. Now let's have a look at the wiring harness which will connect the next bank of cells to the BMS. This goes as the white connector which plugs into the white socket on the BMS, and let's have a look at the wiring. In similar fashion to the other connector, we have a black wire in the first position there which will be connected to the negative of cell number 9. Then white is positive cell number 9, yellow positive cell number 10, orange positive cell number 11, and red positive cell number 12. Then we have 2 black wires which are connected to the temperature sensor, similar to the other. Then the next white wire here goes to positive cell number 13, yellow positive cell number 14, orange positive cell number 15, and red positive cell number 16. So that's how those are going to be connected. These are delivered from the factory without any lugs on the wires. So I'm going to go away and fit some 4mm lugs in similar fashion to the first cell there, and we'll pick it up once that's been done. So here we are, we've wired up the second bank of cells to form the complete battery. From cell number 8 we've gone across here to cell number 9. That's cell 10, 11, 12, 13, 14, 15 and 16. This is our positive output, which should be around about 52 volts or thereabouts. We'll check that presently. And we've wired up the second wiring harness in a similar fashion. I've connected the negative line of my meter to the 0 volts line on the battery, and now I'm going to test the voltages with reference to 0 on the white wiring harness. So this should be about 26 volts, yes, because that's connected to the junction of cell 8 and 9. Then the next one should be 29.7, yes, 33, yes, 36 odd, yes, 39.6. Then that's the first temperature sensor. Then this one should be number 13, 42.9, 46.2, 49.5, 52.8, and our next temperature sensor. This is how we wire up the BMS board. We start off with the negative line to the 0 voltage of the battery. Then the next thing we do is we connect the black wiring harness, then the white wiring harness, then the LCD display, and then finally we'll connect the positive of the battery. So we check the polarity by putting the negative lead from the meter on the negative terminal on the BMS and the positive lead from the meter on the positive lead of the BMS, and that should give us a positive voltage. So let's see what we've got. Positive 55.24. Just as another check, let's reverse the leads and then we should get a negative voltage. Negative 55.24. Looks like we're good to go. We've connected up the positive line from the battery over here, and it looks as if nothing's happened. And that is because we need to press the reset button on the back of the BMS board. Let's do that. The system check takes place with the lights running across there, and the display has come on. So it looks like we have success. By pressing the top button, we can see what the pack voltage is, what the current is coming in, going out. Nothing in this case. And the state of charge is 98%. Button number 3 brings up the choices. We can scroll up and down using button number 4. Let's look at the power cables in the system. The power cables in the system should be 35 square millimeter cables to carry a 5 kilowatt load, which is the maximum that the battery will deliver for a short period of time. The negative cable goes from the negative terminal of cell number 1 to the B minus terminal on the BMS. The positive cable goes from the positive terminal of cell number 16 to the B plus bus bar on the BMS. The load cables, the negative goes from the other side of this shunt to the load, and the positive goes from the P plus bus bar on the BMS to the load. Apex do a 23-page English PDF manual for this BMS. It's technically good, although the English is a bit strange at times. A link to the manual is shown down below. If you found this video useful, please click the subscribe button to follow my channel. Thanks for watching. See you next time.